Good morning and welcome to the next AIM2Learn webinar. My name is Matt Minner. I'm with Catalyst Connection, the lead organization of the AIM Hire Consortium, which is bringing you this webinar today. And today I'm joined by Arif Sirinterlikci with Robert Morris University, and he's going to talk with us about 3D scanning. How are you doing today, Arif?
Fine, thank you. How about yourself?
I'm doing well. Great. Thanks for joining us. I'm just going to get into a little brief overview here on AIM Hire, just so those on the line who may not be familiar are aware. So we'll start with that, and then I'll turn it over to Arif. So the AIM Hire Consortium is a program that launched in August of 2020, funded by the Department of Defense, focused on supporting the defense manufacturing ecosystem here in Southwest Pennsylvania and West Virginia, with a focus on adoption of advanced manufacturing technologies like AI, machine learning, robotics, additive manufacturing, and the like. It provides various benefits to supply chain members, both current and those who would like to find opportunities within the defense supply chain, such as various convenings and supplier forums and things of that nature. So that's the overall view of what the AIM Hire Consortium is. And it brings together a wide range of resources from economic and workforce development, technical institutes such as America Makes and ARM, and the university community here in the region, with Carnegie Mellon, Pitt, West Virginia University, and of course, Robert Morris University. And one resource that I want to bring to everyone's attention is our supplier capabilities database that you can access through the aimhireconsortium.org website. This database aims to bring together manufacturers across the region to be a resource for tier 1 and prime military and defense contractors looking for sources of supply here locally. And so with this, you're able to highlight your capabilities of your particular organization, both from the manufacturing and support side, but with the focus on manufacturing and highlighting different certifications, QMS systems, cybersecurity status, etc. So it's a really powerful tool that we're working to use to connect the regional supply base. So with that, I would like to turn it over to Arif to talk to us about 3D scanning. So here I've given you the board, Arif, so you can go ahead and share your slides.
Thanks, Matt. Welcome to our 3D scanning presentation. My name is Arif Sirinterlikci, and I'm with two of my students, Jacob Thomas and Michael Katzmanich, and they will have some input as well, or you will see them in some of our videos. Now, this is an introductory presentation on 3D scanning. If you have additional information needs, you can always contact us through Matt Minner or the AIM Hire Consortium. We would like to help you if you need some help in your projects relevant to 3D scanning. So, in terms of
do you want to go ahead and put it in slideshow mode, Arif? There we go.
Anyway, the outline of my presentation here, given here, I will talk briefly about reverse engineering, 3D scanning's relation to reverse engineering. Then we will talk about 3D scanning processes, including photogrammetry as well. Naturally, we will give information on associated technologies, data forms, and data manipulation methods. And you will see some short videos, as well as be exposed to some of our case studies, which may not be related to defense applications. So we had a demo planned in place of the live demo. We're gonna show you some videos, short videos for that. And then we will talk about resulting file format. you are familiar with reverse engineering, I'm assuming. It is comprised of two parts. One is the methodology, so we are not concerned about that in this presentation. And we will talk about reverse engineering technology. And actually, most of what you see in the metrology, the measurement science, the tools will apply to reverse engineering. But we will focus on 3D scanners. In terms of 3D scanning processes and associated technologies, again, we will start with photogrammetry and 2D scanners, smartphones. Then we will move on to 3D scanning, following different types of scanning processes and equipment. In terms of photogrammetry and 2D scanners, we have done some work in the area. Again, we were using smartphones to scan objects. You will see two examples of that on the slide here, the spider and the skull. And the process is about taking two-dimensional photographs using smartphones or other smart devices and converting them into three-dimensional models using computer algorithms. You see the picture on the left, there's a drone. That is representing the type and the number of pictures we take, number of shots we take to generate a 3D model using photogrammetry. And you can see that large number of blue images representing the shot positions. They could be taken straight at the object or at a 10-degree elevation angle. And then lesser number of shots required, and they are represented by the orange images right there, at a 45-degree elevation angle. Then, if you like, you can have also some close-ups as well. All of these pictures are combined by the algorithm to generate a 3D image. And you can see the skull and the spider there. Naturally, spider looks a little bit better. We will give a little bit more information on this in the coming slide here. So the process is made up from 4 different steps. The first, you have to take the images. I was talking about that. The images should have some overlaps. And again, it is hard if you're manually taking these images. But you can use turntables or other, reference mechanisms to aid the process. Again, the blue shots were taken at 10-degree elevation and orange shots were taken at 45-degree elevation, and then some close-ups can be used as well. We use newspaper as a reference. You can also use chroma key backdrop. Just like any other scanning process, the surface reflection, very shiny surfaces generate problems. So you may want to handle that as well using different means, using chalk, using sprays and things like that. And a high megapixel camera with a wide angle ability is a better device. Now, after you take these images, you upload them into a photogrammetry software. Most of these tools are cloud-based, and you're seeing 2 of the examples we used in the past, 1 to 3D Catch and Remake. Remake is now called Recap. It is an Autodesk product. So what these tools do, they basically match different images by looking at their overlaps, because they'll try to stitch all of these photographs into a 3D geometry. Naturally, feature extraction, triangulation, those are the other things you will see similar to other 3D scanning mechanisms. If you're using cloud-based tool, again, no matter how good your computer is, it may take hours or days based on the busyness of the server. Now, in terms of the post-processing, you will also need, just like other 3D scanning mechanisms, you will need to remove noise, get rid of the floating artifacts, patch the holes, and deal with other type of irregularities. For that type of stuff, we use MeshLab or Mesh Mixer software. And you will see we have used other software tools as well. So don't expect your image after the photogrammetry process is done to be a ready-to-print watertight mesh. So let's move on to the 3D scanning technologies. and associated processes. So two major categories of scanners exist today based on the way they capture data. The ones that take single snapshots and scans are the ones that capture multiple images continuously. So our demo videos will show a portable scanner that captures images continuously. You can also classify these 3D scanners as low cost, professional, and industrial grade. It's a very similar classification to 3D printers. We classify them as low cost, a desktop or bench top or lab, office grade, as well as the industrial grade. The scan data is represented in the form of a point cloud or a polygon, a triangular mesh, and some of the scanners will acquire color information. And you'll see the details of different processes, and additional information on these will be given again in the coming slides. After you have multiple scans, all these scans will be brought into a common reference system, and these scans will be aligned and registered based on their overlaps or common features, and then merge into a single scan, a single surface model. In terms of the laser being utilized in the process, I wanted to give more information about the laser scans. So you could have a beam of infrared laser light, that's a common form of laser energy form here for this type of application, basically emitted onto a rotating mirror to be paint the surrounding environment with light. And then you could have also the have your laser scanning head rotate, basically sweeping the laser across the object. If the laser stays, fixed, you may need to use a turntable or manually move the stuff on a rotating fixture. Now, in terms of the naturally the return data, we talked about point clouds and meshes and polygons and things like that. So we will cover these in more detail. There are two types of laser data capture systems. One is the time of flight. So in that case, we measure how long it takes for the laser to come back to our sensor or camera. The second one will be measuring the displacements between the waveform send out and the receive, giving us also precise distance calculation. In the second case, the phase shift systems, the light is modulated with specific waveforms. Now, after some basic information on laser scanning, and again, the laser scanning is used in measuring arms. We can also call them portable CMMs, portable coordinate measurement machines. Those devices can also have fixed probes or touch trigger probes. You're looking at a ferro arm. I have used this for a few years. It has a touch probe on it, as well as a laser scanner. Naturally, this device has to be fixed onto a surface, and its arm resembles an articulated robot arm, and each joint has an encoder. Basically, we establish the position of the tip of the measuring arm using those encoders. Unfortunately, they are prone to vibrations and other environmental constraints, similar to what you may see in CMMs or other devices. They also lack flexibility in terms of the locations where they can be used, as well as the shape of the objects they can scan. So again, from my experience using a ferro arm, it was an excellent tool, but if you handle that roughly, it was very sensitive, so we had to be calibrating it. And when we tried to, replace this with another one, it was $100-some thousand, $150,000. So another type of 3D scanner is the optical tracking based device. So you have an external optical device is basically looking at the position of the 3D scanner. You can see that in the figure. And it can provide very good accuracy and excellent precision throughout the measurement volume. So which means there are some issues associated with these devices as well. And again, the optical tracker binds binds itself to the scanner. Passive or active targets are used as well in the process. Now, in terms of the, we talked about the strength of the technology, but it has also its limitations. The optical tracker must always have a clear and direct line of sight to the 3D scanner. Trackers may have limited working volume, and extending the scanning parameters add complexity to the process can also induce additional problems. Now, in terms of the their costs, also they may be a little bit more expensive than portable 3D scanners. So I will show you a list of 3D scanners in a little bit, and you can see their accuracies, their costs, and that list is made from portable scanners. Now, many types of portable scanners are available. They use the laser or white light technologies as the energy form. Now, you're seeing a Creaform's handy scan, and I have used that one as well over the years. With the laser being projected onto the scans, you will see these guys having 2 cameras. So the process is called stereoscopic vision. So in terms of the scanning aids, they could be working with positioning targets or the object's natural features or textures. And again, if you use a mix of positioning types, the process called hybrid positioning. Naturally, the portable scanners are transported easily with minimum effort. They can be combining multiple positioning methods. We talked about the positioning dots and features or the textures, things like that. They can acquire a large number of points per second and rebuild the 3D triangular mesh live during the scanning process. You're going to see that in the videos. Handheld scanners do not require a mechanical link like the previous type, and they don't need a tracker. So this enables them to reach narrow and enclosed areas, so you can do well with the details of the object. They can, since they are focusing on parts of the object you're trying to scan, the errors can stack up as the scanning volume grows. But again, these can be handled as well, use of positioning targets or photogrammetry aids, additional tools as well. And then don't forget about hybrid positioning. So I have this list of 3D scanners pulled up from all3dp.com. It's basically, it is listing accuracies of these different portable scanners, the energy method, laser triangulation, structured light, LiDAR, and sometimes you will see the combinations of these being utilized. And then the work volumes, the scanning, maximum scanning areas right there, as well as the market price. And you can see that anywhere from a few $100s to $40,000 different forms of scanners. And we just bought an AIM scan, and AIM scan is basically about $9,000, but it's a very good scanner. So in terms of structured light, and again, talking about AIM scan uses structured light. Basically, the projector projects a known pattern, a horizontal bar. You can see that from the image. And then 2 cameras, again, we talked about that before, look at the image, and anywhere from, subtle changes to sudden features can be detected from this based on the deformation of the information returned from the object you're trying to scan. In including the depth and additional surface information. Now, structured light systems, scanners, they may also use a single camera, but mostly they use two cameras, generate very high quality data, deliver excellent resolution. And again, you can capture, based on the resolution, small features can be captured. Since you are acquiring large quantities of data, and you need to have multiple scans, the handling of the scans actually has to be done offline. It's different than what we spoke about, the free-form sender scan, or the scanner that you will see in the videos in a little bit. So multiple scans required. Again, all of these take time to put together, so there is a drawback. Now, in terms of the 3D scanning workflow, we have the 3 steps of the scanning. So we have the point cloud phase, we move to the polygon phase, and then we generate surface models from there. A simple example, from the picture I was given a task of scanning Robert Morris's plaster pattern. We are treating that as a bust here in 2006, and I didn't have all these technologies available to me. So I use a Minolta Vivid 910 laser scanner. And my turntable was so small, so I had to build a turntable. 122 shots taken at 12-degree intervals. And the information, the data was fed into Geometric Studio. The scan we generated was 2 gigabytes in size, so I had to go in there and reduce the number of triangles, the polygons. But before I could even rotate the piece, I had to add a ramp here. So you're seeing different features and parts of the point cloud phase. So you can filter points, you can reduce noise, you can see that noise being reduced in the picture. You can fill holes, you can also register and merge. The next slide also gives the same type of information, but in this one, it is explaining what registration as merging is about. So again, if you have multiple scans in the point cloud phase, you can try to align these by doing registration. Again, the software will allow you to put these things together, identifying the similar features in different scans, and then you can merge everything into a single surface model. The next step will be at the end, single surface model. The next step is the polygon phase from the point cloud. So you still have similar features available compared to the point cloud phase. You can also do smoothing, relaxing, sharpening, things like that, and fill in the holes as well in the polygon phase. So you're looking at the polygon file generated in the Geometric Studio software. And then the other example is about filling in holes. So anywhere from flat surfaces, surface segments, as well as polynomial-based ones, you can actually use that. Naturally, the information can be saved. In this case, I was able to save it in the NURBS format, and to 3D print, we had to move to the STL, which will lose information. Another case study we have here, we use the Ferro Arm as well as the Kinect from Microsoft Xbox. Now the Kinect has version 1 and version 2. I think they're obsolete right now. They use the triangulation as well as the structured light, but the Kinect version 2, I think, may be different and use time of flight laser measurements. So you're looking at a scanned foot of an anatomical model, and we basically, from that point on, use 2 different scanners, use different software tools, and try to generate an ankle and foot orthotics. Excuse me. So we try to compare the 2 processes. Again, we have the Ferro Arm Platinum available for us at the time. We try to compare that with the Xbox Kinect, and you can see that the Xbox Kinect scanned the image in 2 minutes compared to 25 minutes, and it was much more easier to actually scan the object. So that's why it is used in many different applications, including engineering development and research. So I'm not going to get into the accuracy comparison of both of these things and pros and cons of the Kinect, but these slides are available, or anybody watches this webinar, you can read, ask us questions. At the end, so we gain a few minutes in preparing the end-to-end robotic device here, but especially if you look at the scan times and the data manipulation, it happened very quickly. Now, both of these software required a lot of work. Actually, we had to reduce the number of polygons without losing the details. And again, if you use some of these scanners, you're not going to capture the data as well. But again, in my slides and this presentation, will give you information about what is more accurate, what can capture small details. I already talked a little bit about those. Now, our demo is, we were going to do a live demo. We are using Occipital's structure core. It's only a $400 to $600 scanner. It uses infrared light beam, and it's a portable scanner. Basically, it puts out unique infrared patterns of dots in front. And then I have these slides on different forms of data files, file formats. The film box, I will not talk about it, but 3MF and AMF is being used in the 3D printing world. There is a comparison of some of these data file formats at that link. You can also check that. It's a nice comparison. And then we have definitions of OBJ, PLY, STL, and VRML formats given here. And again, probably the OBJ will be one of the good ones to look at. The freeform curves and surfaces are included because you can't do that with STL, including color and texture information. And again, some of these are available in AMF and 3MF formats. The OBJ can also refer to material library, so the material information can be done. Again, most of what I do today still uses STL. And you need to take a look at these things. And a lot of the software generates STL automatically. You can try to control triangulation, chord height by making triangles small, the distances between the triangles, as well as the angles between the triangles, between neighboring triangles. So STL, strangely, doesn't carry unit information. And if you have done enough work, you already know that by now. So let's go and take a look at our scanning exercise here. So before we do any additional work, we have to do calibration. And you're seeing the calibration example here. So basically, the scanner is attached to an iPad, and we are calibrating both the digital camera and the infrared camera here. And you can do this inside or outside. I believe procedures are slightly different, and you can see both images. They have to overlap. That's how we are setting the calibration here. So this is in real time. You can see that how easy to calibrate this. It requires a lot of background light, though. In dark days, without light sources, you're not going to be able to calibrate this camera easily. In terms of the scan, basically, you can see that we are walking around the object. Naturally, this is going to scan the table as well. And we can quickly crop that one out of the scan. And you're seeing it's taking a little bit of time because we're trying to maintain the distance. And again, this is a $400 to $600 scanner. And we were also planning to do a demo on AIM2Learn, but I think we're running out of time. And then let's see, in terms of the data manipulation, this is probably one of the longest videos. So we bring in the data, both the scanner and the laptop as the data acquisition device. They have to be on the same Wi-Fi. And then once we bring in all the data, we basically eliminate noise, unwanted surfaces and things like that. And we can save this in all these 4 formats I talked about, OBJ, STL, VRML, as well as PLY. And you see the dots up there, they basically show the scan pattern here. And then we will soon, we will crop the, the bottom. At first, we have to finalize the, image generation, and you will see the table actually in its color, as well as its reflection on the bottom. So in the slides, a 3D print of a similar scan was included in the demo slide. And naturally, we are doing this in a couple of minutes. If you spend a little bit more time, and actually you can scan more complex images. This is just a cleaning bottle. And I am gonna finish the presentation here. And you see that, table showing up. And table colors, basically part of it is reflected on the bottle. And we basically, that blue plane, we can just move it quickly and just do a very simple explanation of, getting rid of unwanted data. You can see that here. Again, thank you for your time. I will stop right here.
Excellent. Thank you so much for that very thorough overview of 3D scanning. A lot of great information. Obviously, you are a wealth of knowledge and resources, Arif. And as he mentioned earlier in the presentation, if you have any questions, feel free to forward them on to me and Matt Minner, which is mminner@catalystconnection.org, and I can get them over to Arif. And let's see, just checking here. And we do have one question that's in the chat here. Is there a scanning technology that can compete for accuracy with a CMM?
Well, again, when you do tactile measurements, their accuracy. Yes, I mean, you will see better and better accuracies. And please take a look at even the portable scanners that you spend for a few $1,000s. Optical-based methods, we are improving them, and we are generating, some good scans here. But you're right, the technical measurement, but we can definitely do well with these scans.
And so are there ways to, like say if you, using those, you're holding the scanner by hand, if you have a more structured way or more consistent way, whether on a tripod or some sort of revolving setup, or even with a robot, are those sort of things able to increase the accuracy?
Correct. Some of the more expensive scanners, naturally, and use of different technologies, yes, we have really decent accuracies. Like I mentioned, structured light scanners. That they could be working with. You can put that on a tripod, like you said, and then they can work with a turntable. So again, we can have better accuracies, and again, this depends on the application.
Right.
Application, but use of tripods, use of hybrid positioning, and if you have a more expensive scanner with better resolution, actually you're going to have accurate results. And again, the website, Matt, gives us a list of different accuracies. I don't know, should I go back to that or not? I think I must have closed it, but if somebody follows that link, and they can look at the different accuracies, and you can see a lot of changes there in terms of the portable devices.
Very good. All right, well, I want to thank you again, Arif, for your time, and your students for joining us today. And thank you everyone for joining in on our AIM to Learn. Next time on May 26th, we will have JARI, which is the Johnstown Area Regional Industries Organization, on with Kongsberg and JWF Industries, 2 defense manufacturers, talking about or giving a preview to their supplier forum that they will be delivering at Showcase for Commerce in the beginning of June. So don't miss that. That'll be a great event. So thank you again. Arif, thank you. And everyone have a great day and a great afternoon.